scale that sets the interactions for the spin 2 part is 1 over n Planck in 4 dimensions. So n Planck controls the strength of the gravitational interactions. So you can think of gravity as an effective field theory, non-renormalizable effective field theory in which the interactions go like 1 over n Planck, and gravity is weak precisely because n Planck is very large. And so that sets that scale. But pi, for the Listy zero mode, its interactions are not set by n Planck, but we'll see they're actually set by a much lower scale lambda, where lambda is given by the cube root of m squared times m Planck. And that's because we have another energy scale in the game, which is the graviton mass. And so if I'm assuming the graviton mass is less than the Planck scale, then what we get is a new scale lambda, which is the strong coupling scale, called the Listy zero mode, which lies intermediate between Planck scale's up here, and then we usually imagine a light graviton mass, and then there's an intermediate scale lambda that sets the strong coupling scale. And what happens for realistic, why this VDZ discontinuity does not occur for actual systems like the solar system, is that within the solar system, the Listy zero mode is not well approximated by the linearized theory. And all the calculation we did here was just a linearized theory. The Listy 2 modes are well approximated by the linearized theory because m Planck is so large. For the normal reason, gravity, that part of gravity is weak. But this part of gravity is actually very strong. And you have to deal with this non-linearly. What happens is that non-linearly, the VDVZ discontinuity goes away, and at least classically, it is true that Einstein Hilbert gravity, i.e. massless gravity, is the massless limit of mass of gravity, but only through non-linear effects, which are called the Einstein mechanism. So I'll have to get to that next slide. Thank you.
Questions? Okay, we're running a little bit late, so let's thank the speaker again. So let's come back tomorrow morning at 9:20. But keep an eye on the weather forecast.